Okay. I'm going to limit this question to just the radius conversation. We're not even going to worry about the height. Yes. They make them, they sell them at the store. Last digit. Oh no, you ain't come back for that.
Yes, I am.
No, you won't. I want something. Keys, wallet, phone, something. Here you go. Have this. Oh, now you're gonna share it with you? Yeah. Hey, he's faster. What?
I don't even want to know more.
Oh, now you're gonna have to share it with him.
I'm just letting you.
Play a game. All right. Duly noted in your file. Okay. The reason I'm only going to ask you for the radius here is because I'm really trying to see if you can analyze the graph. Yes, I know you can plug in the radius and find the additional heights. I don't know what just happened. Okay. Don't want to know. Do you know how to graph that thing from this formula? Hey, that is a great suggestion. If you didn't know what this thing looked like, you could reach over, grab the graphing calculator, assuming you had one, and then you could graph that doggone thing, right? Now, yeah, that is what you want to do. Okay? Now, reading more into this problem, it says that if the cans have a surface area that is less than 1,000 square centimeters. So what I'm trying to focus your attention on here is this part right here. That's your Y1. This part over here is your Y2. Okay? We want to know when the Y1 is smaller than the Y2. Now, your graph is all messed up, right? You're trying to graph this. You're like, man, I don't get a picture that looks like that at all. It's because you don't have the right window. Oh, on the test, there's a question like this. I'm going to give you the window. I'm going to give you the window so that you're not fighting the window issue. Okay? Now, they gave you the window issue, the window right there, right? You got your X min and X max. No, I do not care what your X scale is. You can go by 2s, you can go by, I don't care what you go by, all right? Your Y scale goes from 0 to 3,000. I do suggest you do something different than 1 for the Y scale, right? Maybe like 100 or 200 or 500. But definitely change that scale. I mean, 3,000 little lines, I don't think your calculator is capable. So, get it graphed. I need to see that you can get that kind of picture. Change your window, get it graphed on a calculator. Nice. Are we getting the picture?
Wait,
oh, okay. So, this plus, yeah, so plus and then alpha and then an F1. Oh. And then this is the first one on the list. What?
I don't think that's right.
Well, actually, it is. It's because the stat plot is turned on, so whatever here it says show that plot. So now, we go to the window 0 to 20, 0 to 3,000. I bet you. Yeah. Okay, did you do the other one too? Y equals 1,000. Okay, that's the other one. When you got it, you should. I don't know why it looks different like that.
There we go.
I mean, it's basically the same, unless
Well, no, because like.
type it in right. 2 pi. Oh, 400x squared. Oh, that's 4,000x over x, right? looks much better. Okay, you got a picture that looks like this? Anybody not getting a picture like this, assuming you have a calculator?
I'm getting the swoop, but it doesn't work.
Well, it doesn't have to. The other, did you type in the other equation, 1,000? Got to have both. Must have two equations, y1 and y2, right? Now, how are you going to find these two intersection points? Not the trace button, but something pretty close to it. Calculate what? Intersection points, yes.
I'm sorry.
You don't need that. You need to go down to y2, just like I instructed you. And you need to put in 1,000. Okay? Now when you graph it, you're going to see the same picture that we have up there on screen, right?
I'm doing something wrong.
Okay, did you go 0 to 20 on the x min and x max?
Yep.
You go 0 to 3,000.
That's why. Oh, now find the truth.
Oh, sure. Okay, we need the calculate intersect feature. So go calculate those two intersections. I need the x's. What are the x's? Now, if you're having trouble doing the calculate intersect feature, let me know. Now would be a good time to figure that out. Because you have to be able to do this. All right, so what's my intersection point on the left? What's the x value? 4.61? Or does it go to 4.62?
4.62.
All right, if we're going to round, let's do it right. Okay, how about this other one? 9.65, okay. Okay, I bet you can answer the question now. When is y1 smaller than y2? Do you think it is this red section right here? Nope. I have to agree with you. Do you think it's this red section over here? Nope. Do you think it's the green section in the middle? Okay, then answer the question.
But it's asking for the radius of the height.
Yep, I want to know about the radius. I'm not going to ask about the height. I just want to know about the radius. Tell me, based upon the picture that you see, when is y1 smaller than y2? When is the surface area less than 1,000? You said it was the green section, so you should identify it. Okay, so what's your answer? 4.62 to 9.65. Should we use parentheses or brackets? Parentheses, thank you very much, right? We do not include the endpoints because it did not say equals 1,000. It said less than 1,000. So that is your final answer to this question. We used our graphing calculator to find those intersection points. Yes, I will give you the window. Question?
How do you know that that's the radius? And then
If you look at your variable, the only variable involved in this is the radius. So this has to be radius along the x-axis. What's this along the y-axis? Surface area. That's right. We got radius and surface area. Now, if you wanted to find the height, and truthfully, if we worked for this company and we needed to find the height, we would take those two values and we would plug them into a formula, right? To find height.
Like we know the volume of the cans, right? Volume equals what? Area of the base times the height. So for this, it would be pi r squared h. We know that these cans are 2,000 cubic centimeters because they're 2-liter cans. And so we could take our radius, plug them in, and find the heights. I don't want to waste the time with that at the moment. The point of this question was, could you take the equation, the inequality, analyze it, find the information you needed? Not could you go further with that. So I will ignore the height part of the question for this example. So we will need to be able to use a calculator on questions like this. And I'm pretty sure there's one question like this on the test. Okay, hopefully they wrote that down, you know. Okay, so, and we'll get this. Annotate. Okay, so we're looking at question 37. We probably should factor the top and the bottom. So what does the top factor into? And maybe the bottom as well. Come on, what's that top factor into? X plus what? 4 and x minus 3. Good. What about the bottom? X minus 2, x minus 2? Ah, that's a bummer. There's only one vertical asymptote. You need to find the zeros. You need to find the vertical asymptotes. And you need to find the horizontal asymptote. Now, if you're going to find the horizontal asymptote, I suggest you go back to the original to figure that one out. Okay? So find the zeros, vertical asymptote, horizontal asymptote. Go. Zeros come from the top. I look at the x plus 4 and the x minus 3. And that, you set each one of those times equal to 0, and that'll tell me what the zeros are. Yeah, x equals -4 and positive 3. So those are my x-intercepts. How about my vertical asymptote? There's only one here. That comes from the bottom. Equals 2.
I'm here to do your
Oh
observation.
my goodness. Turn yourself around.
Sir, oh.
Seriously. I mean, turn it
It
around.
was really funny.
Serious.
Oh, here's the closet. That was just what you keep in there.
Well, got
Dead body.
Dead bodies? Yeah, English teachers.
We keep the world coming around, don't we?
Yes.
Ooh, got a dictionary. Oh, you just threw that in there, didn't you? You knew I was coming.
Yeah, I got my
What's this? What's this? Oh, I see. Oh, that's a good place to keep it. I'm always looking. Oh, that is hilarious. That is a really, really good idea.
And then,
So what's this about? That was fun.
Well, at
Okay.
one point I thought I was going to play basketball, but then you have to look on the outside because my door waited. Yeah.
You can't even have bread.
I'm
You're busy. I got good stuff. Yeah.
So I don't know what she has in here going on through there. That's what, and then do you need a textbook to use? One of our.
No, I have one.
Do you have one of those?
I have one. And I studied it last night.
Yeah, those are the copies she has.
Are you coming to, will you be here? I'll be by myself.
Well, right here. I'll leave the door.
How do you use your LCD? Can I use it now?
Yes. Am I still recording this?
Yes,
Oh,
yes,
my
you
God.
are.
This is great.
Say hello to YouTube.
Yeah.
Barrage is one of my favorites.
Watch The Wizard of Oz.
Yeah.
Okay, you know, like when they come into the Emerald City, right? And they say, "Pay no attention to the man behind the curtain," right? Because it's Wizard of Oz and he's talking. Okay, that's right there. You'll pay no attention.
I am not a man behind.
Okay, all right.
I really haven't heard my voice.
Okay, all right.
I'm out, okay?
Okay.
You sure do have a good teacher. So, I'm serious. I hate to say that out loud.
Yeah, she does, really. You know, kind of hurts her feelings, too.
Yeah, good guy there.
All right, so zeros. What do we got? 3 and negative 4? Well, why am I moving that around? I should not be doing that.
Okay, never mind, that's definitely wrong.
That's my
Why? 3 and negative 4? No, that was good. I like that.
Mr. Staley.
Okay.
Okay.
I'll try to keep the door unlocked for
I
you.
have a key.
Oh.
Yeah, this is your car, I think. You got the garage.
Oh my goodness. All right.
Mr. Staley,
Make sure you gas it up, wash it. Okay, what'd you get for the vertical asymptotes? X equals 2, there's only one of them. Okay, how about the horizontal asymptote? How'd you get it?
You divide the limit.
You took the limit as x goes to positive infinity of x squared over x squared.
I remember him saying that.
Yes, take the limit. Don't be one of those people. It's y equals 1. Okay, so now we know. And then we got a horizontal asymptote running through here, right? Y equals 1. And we've got a vertical asymptote over here at x equals 2. And we cross the x-axis at 3 and negative 4. Whoa.
That is weird. That is very weird.
Now, we need to pick some numbers, don't we, and plug them in? All right, so what should we be plugging in? I need something for this section over here. I need something for this section here. So do we have any choices in those two blue sections? 0, excellent choice. And then negative what? Negative 5, sure. Negative 6 would work too. What else? Oh, we need something in here, right there. Who picked that? What do we got in there? 2.5. Yep, we're going to have to go decimal. And then we need something outside here. And, okay, so 4. 4 works. So now we have a number in each of the sections to test. So I suggest you do that. I'm going to get rid of these blue things so that we have more visual. So figure out what's positive and negative. Come on, go. You got your fraction. Let's see if I go with negative 5. That's negative over negative. Ooh, that's a big old positive. Okay, keep going. You got 3 more sections. Shouldn't take you long to think about what you're getting as you plug in these values, positives and negatives. I don't think if this is the original function, they're not all coming out negative. So you plug in the 1, put in negative 3, so negative
here. Okay? So just think about it, and that's why I write these things down and go, 3, 5, 0 over here, 6 over here. Then I go with these numbers. How's it going? Yeah. So we pick those numbers. We found that we needed 4. -5, 0, 2.5, and 4.
That's why I was like, what's
I need something past this 0. I need something between this 0 and this vertical asymptote. I need something between this vertical asymptote and this 0. And something between after this 0.
Okay, let's see if I can catch up to you here. Plugging in 0, I got positive, negative, over, negative, negative. What's that end up being? That's definitely negative, so this section here where the 0 is at is negative. 2.5, ooh, gonna try to squeeze that in here somewhere. Ooh, so that goes in this section right in here. Okay, so we got 2.5 would be a plus, 2.5 minus 3 would be a minus, and a positive and a positive. What do you get when you take?
negative?
That's a negative section right there. Negative section. And then if I plug in a 4, I get positive, positive, over, lots of positives.
Positive.
So that section is positive.
Because if only one of them is negative, then everything's going to be negative.
Yeah, so the second section from the left, it was this one right here. We had plus. So if you have 3 minuses, 2 of them are going to cancel out, but that still will leave you with 1. Okay, folks, I don't know if you know what this picture's looking like, but you are not going to cross the vertical or horizontal asymptotes. So I think you're going to have something that looks like this. Kind of weird.
Oh, I hate that. Wait. Why do
It's
I
got to
hate
get
that?
closer and closer to 1 on the left side. It's got to cross through at -4, be negative, never cross the vertical asymptote, and then between the vertical asymptote and the 0, we're at negative, and then we cross through and become positive, but never cross the horizontal asymptote. Wild.
Why do I hate this thing
Yep.
so much?
It has to go all the way to the vertical asymptote too. So we had to be close to this horizontal asymptote. It's positive, 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 0. Negative, 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 negative.
But I thought
Drops
it
off
could
because it can't touch this.
But I thought it couldn't do that. It couldn't cross the asymptote.
It can cross the x-axis. That's not your vertical asymptote. That's not a horizontal asymptote anymore. The only horizontal asymptote we have is y equals 1. You told me that. Everybody said that was. And then over here, we're negative, 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 negative. We hit 0. Positive, 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 but don't touch the horizontal asymptote. That's a cool one. Now, I've had a few people today.
Wait, go back.
Okay. I've had a few people today, maybe I can draw it in the corner here. I've had a few people today asking about something like this. Let's say it was x plus 1, x minus 2, and x minus 3 is greater than 0. Or greater than or equal to. It doesn't really matter. Okay, so let's say that was the problem. I've had a few people today say, the vertical asymptotes are. Now you look at that thing. What are the vertical asymptotes? There aren't any. Why not?
It's not a rational function. There's no divided by, right? All of our vertical asymptotes come from the denominator. What is this thing? If it's not a rational function, what kind of function is it? Come on. What? Aren't those the polynomial functions?
Didn't I say that?
I didn't hear you.
I definitely said
Neither.
that.
Shit.
Because Thomas was laughing at me.
No, you're right. And polynomial functions don't have.
Isn't the opposite of rational irrational?
Okay. You would think so. Okay, now.
I said polynomial.
Polynomial functions. And the polynomial functions don't have any of what? They don't have any vertical or horizontal asymptotes. Okay? So don't start talking to me about vertical and horizontal asymptotes with a polynomial. What are you looking for? What are you going to find with those three things? Zeros. You're going to find the x-intercepts. Don't let them talk down to you like that.
Yeah, Thomas.
Yeah. Bullying. Mathematical bullying. That's what that is. Okay, we don't tolerate that.
So who really deserves a good grade?
Okay, let me go find a 2-7 question. Let's try, this is 2-7, question 16. 2-7, question 16. I think you probably should factor this right here, because the other two denominators are already factored. So how do you factor x squared minus x? X times x minus 1. It's a little GCF you could pull out of there, right? That's about as, yep.
That was where we had the pluses and the minuses, so the positives and the negatives, right? So wherever you did your work for the plus, minus, that kind of thing. Okay.
I can at the moment, but I can a little, it's in the video for one, which I'll have posted for you, so you could just fast forward to the part you need. If I get a chance, I will, but it might be a little bit of work to do that. Okay, so let's see here. If I factored out the x, what is this denominator missing that the other ones have? How about an x? If you multiply it to the bottom, you must also multiply it to the top. What is this denominator over here missing that the other one had? Do not tell me minus 1. That's what an Algebra 2 kid says. It's missing an x minus 1, right? So we multiply the top and the bottom by x minus 1. They never leave enough room in these problems. Now, if we multiply the entire thing by the common denominator, x times x minus 1, what happens? Hey, we get rid of all the denominators. Hey, what is this times 0? Okay, just making sure you knew that. Okay, but yes, all those denominators are gone, right? So we're really dealing with, what is it? What do I get when I FOIL those together? X squared, 2x minus 1x. What's 2x minus 1x? 1x. And a minus 2. Okay, then we got this thing right here, negative 4x. And I need to erase because it looks really messy. Then we have this plus 2. And what does it all equal? Come on, what number does it equal? 0, right. I wish there were more people of you that said that. All right, solve it. Go.
Combine any like terms you got, right?
If you simplify it. Oh, it's a plus.
That is funny.
Sorry.
Hey, send that to me. Okay. And then get back on these notes. Get it. Like, there's a whole lot that I've been dealing with you trying to get you ready for this testing, right? What did you get that you're It's a funny picture. What?
You should put the basketball hoop.
Right, yeah. Oh, you mean this? VCR basketball? That's back when we had VCR.
What's a
Yeah.
VCR?
Okay, you guys take some history classes. Yeah, she did. She did.
Is that the giant tape?
The giant tapes. Of course it is.
We should watch them straight to VHS Disney movies.
X squared minus 3x. Is that it? Holy cow, this is easier than I thought.
Wow.
Can you factor that, or are you going to hit it with the quadratic formula? What are you going to do? Okay, the choices were factor it or hit it with the quadratic formula. I didn't hear x anywhere in those choices. Factor it or quadratic formula. What do you got? Factor it would be a good idea. And in order to factor it, we could pull out the GCF, which happens to be x, if that's what you meant. Okay.
Yep.
Mm-hmm.
So with
The two choice. What are the two answers? What are the two? I'm going to write this down. Possible answers. Okay, so my possible answers are x equals 0. We get that from this factor. And x equals 3. Now, why am I saying possible answers? One of them, or even both of them, might be extraneous. So this is the least favorite part of your life, plugging them back into the original equation to see if it works. Now, one of them is very obvious that it doesn't work. Which one does not work? 0 doesn't work in this case because, why is that a bad one? The answer's right here, folks. You can see that it would cause you a problem in the very first fraction because you can't divide by 0. So that one is definitely extraneous and can be thrown out. So yes, we would have to 3 plus 2 over 3 minus 4 over 3 minus 1 plus 2 over 3 squared minus 3. So what do we got there? 5/3 minus 4/2 plus 2/6. 9 minus 3 is 6. Is that equal to 0?
No.
Okay, well this might not be as bad as you think. What is 2 over 6? That's 1/3, okay? So what is 1/3 plus 5/3? What's 1/3 plus 2/3? Or I'm sorry, 5/3 plus 1/3? That's 6/3, which is 2. And then we're subtracting 2. Oh, that worked out nicely. Okay, I'm sure you're going to be grabbing the calculator for that kind of stuff. Yeah? I don't know. I haven't checked my email. I've been busy, really. See, remember, I'm the one writing things down. I think you need to be the one writing things down, too. Oh, my goodness.
Wait, I want to see it.
So very Algebra 2-like stuff. That's why I didn't spend a bunch of time on it. I'm available tomorrow morning and Friday morning, plus we'll be reviewing in class tomorrow. So if you're finding questions out of those that you want to go over, as well as other problems, I have put a review sheet in Canvas for you to look at. If you want to, it should not take you a lot of time. Question 21, and I have specifically made it less than 0. You need, first of all, you can tell it's a polynomial, right? No vertical asymptotes, no horizontal asymptotes, it's just a polynomial. Okay? What are the zeros? None. Thank you very much. What's the leading term? Oops, let's not do that. What is the leading term? 2x to the 4th, right? You take this and multiply it times that. That gives me 2x to the 4th. You should all know your end behavior for that. Okay? With the leading coefficient that's positive, what do you know about the right end behavior? It's going up to infinity. What do you know about the even degree? It's going the same as the right. So we have something that never crosses the x-axis and goes up on both sides. Answer the doggone question. When is that polynomial less than 0? Never. What if I flipped it around and said greater than 0? I know the word you're going to use is always, but specifically negative infinity to infinity, right? All right? Obviously, if there's no solution, you can write no solution, which is the case here. Let me shut this off.